Now, another thing that could happen is, well, what if the data that's going back to my server is actually a physical file? So I'm going to let the user upload files to my web application. Okay. This is one of those features that, if I'm responsible for the application and all of a sudden I'm presented with the task to implement this feature, I get a little nervous because I'm like, oh, we're going to actually let people upload stuff to the app. Oh, I don't want to do this. But sometimes you have to do this because it's just part of how the application works, right? So if you're going to let people upload files to your application, I have like a little checklist here of some things you should think about, some things you should do, okay? So the first one here, it says use a whitelist of file extensions. So you probably know what files are okay for the user to be able to upload. Maybe .txt files or .pdfs, or there's probably a limited list, okay? If you have a case where it's like a, I don't know, a trouble ticket reporting system, and you're gonna let the user attach files to trouble tickets, and they can attach any file they want. Well, hopefully that kind of system is behind some sort of authentication. So, only authenticated users are allowed to do that kind of thing, because now it can get really problematic. But let's say it's a public facing site and you can let users upload files because they can upload like an application for services or something, right? All right, so when the file is uploaded, we're gonna look at the file extension of the file they're uploading and make sure it's in our whitelist. But hold on a minute. If I'm the user uploading the file, I can change the extension to anything I want. So you might say that we're only gonna allow PDFs, but I could have a Word document and I could just change it from .docx to .pdf and then upload it. So the second part here is that on the server side, at the moment where this file enters into your application, you should also be doing some additional file type verification. Now, what that looks like depends on what kind of files that you think are okay. So for example, if you're only gonna accept text files, and you know that those text files, the first few lines are in a certain format, when you accept the incoming file, the first thing you do is you sort of look at the first few lines in the file and make sure it matches up with what you're expecting, right? So the user's not trying to like trick you into something else, okay? But there are also third-party components and libraries you can get that you can install in your application, where when you give it an array of bytes, it can tell you, true, false, or whether or not that's a valid, PDF file or Word document or whatever, just to make sure people aren't trying to upload like executables and things like that, right? So it may be possible for you to do number 2 there on your own, or you may look for another component that can help you do number 2 there. Number 3, if possible, use some sort of malware virus scanning component. So if people are uploading files, it would be helpful if you've got something you can use to help to sort of check that file for bad things. Ideally, if you've got something out in front of your web server that's going to be doing that kind of scanning before the file ever gets to your application, that's great. And that's probably the best way to do that. If not, you might want to look to some other component you can use to help do that work for you. Use extra caution for file types that can include embedded threats. So for example, Office files like Excel documents, Word documents can have like VBA macros and things in them, which contain executable instructions basically. And so those files you have to use really extra caution, okay? Especially when you go to actually maybe to open them or process them or something, you should look to see if the APIs you're using to automate Word has a way that you can like disable the execution of macros, things like that. But that's dependent upon the kind of file you're working with. But you should be extra caution there. Enforce a maximum name, length, and file size. So this is something we can do at the web server level, where by default IIS will accept requests up to 30 megabytes in size. So you can decrease that size if you know that people are only supposed to upload files that are like 2 meg, 3 meg, something like that, right? Make it smaller. And also the name length. Now, personally here, I don't care for allowing users to pick the names of the files, at least the name of the file that's going to end up on disk. So what may happen is they upload a file, and then when I show them that file later, like as an attachment to a trouble ticket or something, I can show them the name that they chose in the UI, but the actual name that I give the file on disk is different, okay? Because I really don't want the user to give me some sort of string that then I use to attempt to name the file that on disk, because it can just lead to all sorts of bad issues. Store uploaded files outside of the web root. If you're uploading files and then you're storing those on the disk, the worst thing you can do is like save those onto the C drive or something. Because kind of like we talked about yesterday, I don't want somebody to have the ability to kind of fill up my system drive and cause the system to become unresponsive or all sorts of bad things. So At the very least, it should be off on like, the D drive, the F drive, whatever, or some network volume. Or in our case of Accelerate, we've got some places where people can upload files, and we actually push them into Amazon's S3 storage service. So it's not even on our infrastructure. We just have some place we can dump the files. And it's cool because it's not even really on a server in that case. It's just some network attached storage in effect. That's ideal. So some basic stuff. Other than that, it kind of varies and depends on sort of what files you're accepting and what you plan to do with those files, and whether or not you programmatically intend to open those files later, in which case I want to think about least privilege and make sure whatever code is sort of trying to open those files is running with very highly restricted permissions, so that if that particular file contains something malicious or contains executable code, that it's not going to cause trouble, right? But it definitely requires some thought and to basically step carefully, right, when you start accepting files from end users. Okay, here's another OWASP top 10 item, XML external entities. XML as a file format is super cool, been around for a while now, and it also has some extensions to it to do some really interesting things. And one of the things that is interesting is that an XML document can contain what we call an external entity. And so here's like a quick example of an XML file with this external entity that points to some file in the etc directory called password, the password file. And so when you go to parse this XML and that external entity gets dereferenced, it can lead to bad things, okay? So when this can be an issue is anytime your application accepts XML from an untrusted source. So if you have some sort of like web service that accepts incoming XML, what if that incoming XML ends up containing some external entities within it? So when it ends up getting parsed by the framework, bad things could be triggered via an upload to a common location. So you let people upload XML files to some like folder somewhere, some Dropbox, and then you have code that reads those files, parses them, and then does something based on what's in there. If there's an external entity in there, potentially there's a problem. Or as a fragment that is inserted into an XML document. So you accept some incoming data from a client, and then that incoming data that comes from the client ends up being inserted into some XML somewhere. Then at some point later, that XML is parsed. There's an external entity that gets dereferenced, potential issue. This is another form of injection, really. Okay. So when I talked about injection on day one, and I said you never trust anything coming from the client. You always look at your entry points. You think about what you're doing with that stuff. It's just this again. This is just a specific form of it, right? Now, this may not be applicable to your application because you might say, well, we don't have any places where we're accepting XML data from an untrusted source, so we're fine. Okay, cool. But if you are, some quick things you can do here. So the first one is, it says, when possible, use less complex data formats such as JSON. So in other words, XML external entities is a potentially vulnerability. So how do you avoid the vulnerability? Don't use XML. All right, sure, that works. Okay. So we use something like JSON or whatever that doesn't have that sort of external entity capability. That may not be an option for you though, and so that's okay, because we've got some other things. One, make sure you're using modern XML parsers and libraries, so upgrade and kind of patch those, because XML parsing libraries and things have been sort of updated to account for this kind of thing. If using SOAP, which is our protocol for certain types of XML-based services, use SOAP 1.2 or higher. In .NET, disable XML external entity and DTD processing in XML parsers. So the different XML parsers that are available in .NET, like XML document, XML reader, things like that, they have options you can specify to disable this sort of capability, because you probably don't need it, right? So you turn it off so that when you parse these documents, those external entities don't get dereferenced, okay? Now, if you're using .NET 4.5.2 or later, then this sort of stuff is turned off by default, and so you don't have an issue. If you're using a version older than that, then you have to explicitly set the options to make sure to disable that, okay? And then, of course, we still want to have input validation. Anytime we're accepting anything coming in, we're doing input validation. And in this case, it's not hard really to check for the existence of this sort of stuff, right? So you can look at the incoming data and see if this sort of stuff is present in the XML before you then actually use it or do anything with it, okay? So yeah, all right, but this is an OWASP top 10 item. because, it is out there and we see it, in places. So just ask yourself the question, does this apply to the application that I'm responsible for or I'm involved with? And then work your way down the list and see if you can. I would also probably recommend, if you think this is an issue for one of your applications, go to the OWASP website, click on the XML external entities area, read a little more about it, some of the details and things, and go from there, right? But of course, if you're just not aware that this exists, well, that's the first hurdle to get over, right? All right, so we got a few more OWASP top 10 items. Sensitive data exposure. We've sort of mentioned it at one point, but let's say a few more things. So some checklists here a little bit. Number one, is any data sent in clear text? Then you might say, oh no, well, we're using HTTPS everywhere, so nothing's being sent in clear text. Is that the only way data comes out of your application is via, web responses via HTTPS? Or does your application also send email messages or allow access via FTP? Well, pay attention to those things and make sure your application isn't exposing sensitive data. What about between tiers? So when, say, the HTTPS arrives at your load balancer terminates the HTTPS, and then the communication from your load balancer to your web servers happens via HTTP. Now, this may be okay, depending on where this sort of channel exists. If it's within your infrastructure in your local network, it may be fine. If this is happening in AWS's infrastructure on their network, you may not be too happy about this channel being clear text, okay? So you just have to think about, the flow of data between different places in your infrastructure and whether it's okay for certain channels to be HTTP, okay, or clear text. Is sensitive data stored in clear text? Sometimes people, things like database backups, they just don't think about it. That when they're creating backups of their database, those backups are stored in an unencrypted form in places that are maybe not as secure as they really should be. And so that's something to think about. Are any old or weak cryptographic algorithms in use? Maybe there's an application that does do symmetric encryption, but that application was built, 10, 15 years ago, and it's using RC2, which you really need to get off of that and use a different algorithm, right? Is proper key management and rotation in place? If you're doing something like symmetric encryption, how are you protecting the keys? Where are they being stored? Are you changing them from time to time, okay? And again, I can't really give you best practice here on how often should you rotate your keys and where should you store them, because this is highly variable depending on your environment and what options are available to you. So as far as where you store your keys, there's a specific place in the Windows operating system that you can use. Linux, same thing. Or if you're using another host like AWS or Azure, there's services that they provide for storing things like cryptographic keys. How often you rotate them, a lot of times depends on just how sensitive the data is that we're talking about. And sort of what your threat vectors look like. So that's up to you. Probably, once a month might be a good starting point, but you could do less or more, right? Depends. Identify what data is sensitive according to privacy laws, regulatory requirements, or business needs. So it's a good idea, and somebody mentioned something along these lines earlier to me, which is, yes, all the developers on the team should at least have somewhat of an idea of the different types of data that you're working with and which pieces of information we can consider sensitive to one degree or another, right? Some people may not consider birth dates to be sensitive. In other environments, birthdays are considered extremely sensitive. So, right, everybody should have an idea about that. So that way, when you're writing new code or you're extending features and you're working with something like social security numbers or birth dates or whatever, you have to know, which things your organization considers to be sensitive and could have implications when it comes to, legal things and stuff like this. And when I go places where people deal with people's medical information and stuff like that, it gets very, very touchy, right? And so people should be aware of that. Don't store sensitive data unnecessarily, right? We mentioned this the other day, which is the only data that cannot be stolen is data that you don't have. And so when I'm looking at, okay, we need a way to encrypt this data so that it doesn't get exposed. My first question is not, which algorithm should we use? My first question is, do we really need to be storing this? And if the answer is yes, okay, well, then I'll go to step two. We don't want to just skip over that question because sometimes you can maybe avoid just storing it altogether, or maybe one system does need it, but some other component of the system doesn't actually need that information, right? So we can sort of unburden that system by not letting that system have that particular piece of data because it doesn't need it. Because you might have a system that deals with employee objects, and that system ends up having some complexity involved because it has to protect social security numbers. But then you look at that particular application, you say, well, it never uses social security numbers anywhere in the app. So why is that app even retrieving them? And then you modify things a little bit, right? Encrypt all sensitive data at rest. Encrypt all data in transit with TLS and HSTS potentially. Here's a good one. Disable caching for responses that contain sensitive data. Caching is cool, but you have to be careful with caching because sometimes what people end up doing is they'll turn on some caching capabilities either in the web server or in ASP.NET, for example, and that caching functionality actually is triggered before you get to the part where the authentication happens. So I make a request as a logged in user, it does the authentication, gives me access to the data, I retrieve the data, and then the data gets cached. Now I log out, I make a request for that data again, and then it hits the cache, and then the cache just returns the data before it ever gets to the part where it checks to see if I've been authenticated. So be careful, right? Like for example, in IIS, there is some different levels of caching that you can enable, and one of them is something called kernel mode caching, which is very, very high performance caching that occurs at the kernel level down at HTTP sys. And so that happens before it gets to any of the other stuff like authentication, request filtering, and all that other cool things. So just be careful that you don't end up caching responses for something that is sensitive. And I mentioned this the other day. One easy way to test for that is to do a session as an authentic user, record those requests, and then replay those requests as a non-authenticated user and see if any of them work, right? Store passwords using salted hashing functions. We mentioned that one already. Don't send data to a client that is not needed or not appropriate for the end user. We talked about this one earlier too, right? Don't have detailed error messages that give up too much information. And developer comments in your HTML. Just make sure you're not sending things down to the client in your comments, in your HTML comments that really don't belong there, okay? Platform vulnerabilities. This is another OWASP top 10 item. Identify all of the components and versions you are using. So in your applications, right, you should know what third-party things you're using and stay informed, right? Like I think I mentioned this before, right? Stay on top of when new versions come out, and if any security things have been patched, which may motivate you to kind of move to a newer version. Because you might say, well, we don't have time to put forth the effort to move to that newer version of that component. Well, yeah, but if that newer version fixes a very important security issue, then you may elevate that higher in your priority list to upgrade to the newer version of that component, right? But you have to know about it, right? You have to review the release notes or whatever when new versions come out so that you can know when those things happen. Stay informed, right? Monitor industry news about newly discovered vulnerabilities, right? Keep in the know so you know when stuff happens and you can do stuff. Or, you know, when you read about other people that have had security incidents, you read about, well, what happened? Why did it happen? What did they do about it? You know, learn from others before it happens to you. All right, so apply OS and component updates on a regular basis. That sounds simple, but you'd be surprised how many people are not on top of that, just making sure you have either automatic updates or some policy for always installing those updates, because this is stuff that's, you know, you got to keep up with what's happening. And establish security policies governing component use. So when I want to use some new third-party component that we've never used before, what does that process look like? You know, somebody somewhere should make the call whether that's okay or not. And then, you know, generate some documentation, which is, now that we've decided to start using this component, here's where you go to find when new updates are released. Here's how often you should do that, you know, have something so it just doesn't sneak under the radar, right? Unvalidated redirects and forwards. This is one I think we also touched on, which is whenever you're sending your users to some other place, don't just blindly send them somewhere based on something coming from the client. Okay, have some sort of validation, some sort of check, or some sort of limited possible places where you can go, because you don't want the ability for somebody to manipulate that to force your users to, you know, go off to some other place. We call this unvalidated redirects and forwards. Just really briefly, the difference between a redirect and a forward. In the case of a redirect, a request is made to the server sends back a redirect message that tells the browser to go somewhere else, and so then the browser goes somewhere else, the address bar changes, they're at a different place. A forward is browser makes a request, server receives it, server then actually goes and returns some other different page in response to that request. So the browser got some older, completely different content, but the URL did not change, right? That would be considered a forward versus a redirect. In both cases, though, we don't want to do that unless we're sure that it's going to be okay, right? Insufficient logging and monitoring. So this is an important one, which is every major security incident, if you look at how bad did it get, that's usually directly influenced by how good was their logging and monitoring. In other words, how soon after the vulnerability happened or the exploit happened, did they become aware of it? And if it was like a few hours, then maybe the damage can be, controlled pretty well. If it was, days, months, weeks, years, it just gets exponentially worse, right? And so in a lot of cases, something's going to happen. May not happen today, may not happen next week, but at some point something's going to happen. So make sure you've got something in place so that if something does happen, you know about it and you know about it soon, right? So that you can take appropriate action. So all applications should have good sort of logging and monitoring, but the better you can do with this, the happier everybody will be. Now, one thing I want to mention about this, it says ensure all login, access control, and input validation failures are logged. So input validation failures, sure, if I've got all sorts of really great input validation and that stuff is being triggered because people are submitting evil, nasty stuff, I want to know about that. So that sort of stuff should be logged so I can go and review the logs and see that this kind of stuff is happening. When it comes to access control and login, a lot of places that I go, people will log login failures, but they tend not to log login successes. And they say, well, yeah, we don't need to log in successes because login successes, I mean, that's what the system is working normally. Everything's fine. They provided the right password. Why am I going to fill up my logs with those kinds of things? But then think about when you go back to look at your logs in the future for forensic analysis, right? To find out what happened and when did it happen and what led up to it happening. And so there was a vulnerability. So I decide to attack your system at 3 o'clock in the morning on a Sunday. And you are logging login failures, but you're not logging login successes. So I'm guessing at usernames and passwords. And so if you look at your web server log from 3 a.m. on Sunday, you see login failure, login failure, login failure, login failure, login failure. Now, if you were logging login successes as well, instead what you would see for that log at 3 a.m. on Sunday is login failure, login failure, login failure, login success. It's important to kind of know if somebody is trying to penetrate your system, I want to see all of their failures, but I also want to see if they managed to get in, right? Because that's a completely different situation when I'm looking at sort of that audit trail in the logs, right? And so you just want to make sure you've got adequate stuff in there. And one of the things is, when something bad does happen, typically I don't hear the developer or whoever's responsible for investigating the incident that, yeah, we tried to figure out what went wrong, but we couldn't figure it out because we had too much information. Usually doesn't happen, right? And the other thing is logging is just really, really good as well for debugging purposes, right? Tracking down issues and fixing problems. So lots of good reasons to have good logging and alerting too. Maybe send an email when something interesting happens or a text message or whatever. Have something to prevent integrity controls to prevent tampering or deletion. So for example, if you're using a database table to record log entries, how about if you make that database table append only? So new records can be added, but records cannot be deleted, okay? Because you don't want somebody who's able to actually compromise the server to go, clean up their tracks and remove what they did. Now, just to give you sort of my personal favorite here for the Accelerate application and other applications I work on, what I end up using is a very, very popular now logging framework for .NET called Serolog. And even the Microsoft devs now will typically use this in their demos and things, and it's kind of their favorite as well. So this is the framework that you plug in that actually allows you to, write your log entries. So you can inject code in different places in your app, like when your validation fails or when your login fails, you can write a nice little log entry. And what's really cool about this too is not only can this write to like a file or a database, but I combine this with another product called Seq, which is SEQ. And so you can use this combined with Serolog to basically you have another server sitting out there. So all of your applications are running and they're using Serolog, but the Serolog entries actually get sent asynchronously in the background to this centralized server where you record all your logs. Okay, so it's off the box, which is nice. And it's essential if you're doing something like a cluster or a web farm. And so this is the Accelerate Seek server. So this is seq.accelerate.com. And so you can see here, the public website is logging out all sorts of interesting information, like when contact form submissions happen without a reCAPTCHA, but we still log it in here. So that way I can go from time to time, I can go in here and review these and make sure we didn't get any like false positives or anything like that. Here's somebody who downloaded the catalog. These ones that have ad, these are people that landed on our site from some sort of banner ad or Google AdWords search ad. Now where this really pays off though is when we find an error. So here's one that generated a 500, and you can see that not only does it tell me the request to this particular page, but it also gives me the stack trace, and so I can review this and sort of see what happened, and then potentially be able to duplicate it in Visual Studio or whatever. So being able to go through this and have this is like immensely valuable. And of course you can search this and filter it and all sorts of different things. There are all sorts of frameworks out there for doing this kind of stuff. I would just encourage you to, somebody in your organization to do a little research, kind of pick your favorite and, standardize on one and use that moving forward, because having a really solid foundation when it comes to logging and monitoring for your applications is just a good thing for all sorts of reasons, but it's essential for security related things, because when bad things happen, you can take action quickly, because it's kind of like when I'm at a restaurant and the waitress like screws something up. How much I decide to tip is typically not dictated by what the mistake was, but it's what they did after the fact. And it's kind of the same way with your users. So a lot of times users understand that stuff happens, but when you end up revealing their data or their data gets compromised, a lot of times they're less interested in how did this happen, and they're more interested in what did you do about it, okay? And if your response is, well, we didn't really find out about it until 6 months later because our logging and monitoring sucks, it's not great, right? All right, so and this is actually now on the OWASP top 10. This is our number 10 on the top 10 list, is insufficient logging and monitoring.